With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, we are given the question, and the question says a planet revolves in elliptical orbit around the sun. So this is the sun and this is the planet. The linear speed of the planet will be maximum at which position, right? So at which position it would be maximum. So since this is the planet, right? And according to Kepler's second law, right? When a planet travels in an elliptical orbit, right? The line joining the planet and the sun sweeps equal area. So if it is traveling this much and this much in equal interval of time, right? So it sweeps equal area in equal interval of time, right? So that means dA by dt is constant for this, right? The area swept is the rate of area swept is constant, right? So from here, what we can say is dA. So let's say this would be dA and it is extending angle d theta, right? This is dA, the area swept. So that would be equal to r d theta, right? The distance. So what would be the distance? We can assume that this is r from here till here, right? So according to that, dA would be equal to half into base into height, the formula for a triangle, right? So that is the area dA, correct? That would be the perpendicular distance, since the perpendicular would be this one, right? So this distance is r from here, not this. This distance is r, right? So what we can say this to be equal to half into base is r into the height, right? The height is r d theta. So dA by dt, when we differentiate with respect to dt, so that becomes half r into r d theta dt, right? D theta by dt. That would be the final equation. So from here, since it is constant, right? So what we can write this to be equal to half r square d theta by dt would be the radial angular velocity, right? So angular velocity can be written as omega. So that would be constant. So since this is constant, what does that mean is the velocity, the linear v is equal to omega r, right? Half r v would be constant from here, correct? So what we can say is that since r is inversely proportional to v, or v is inversely proportional to r, vice versa, right? So what we can say is that when r is maximum, the velocity would be minimum. And when r is minimum, velocity would be maximum. So the linear speed of the planet will be maximum at least distance when r is very small. So the least distance is perpendicular to this, that is at A, right? So at A, we would have maximum linear speed. So C is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.